This is a review of Cat 2, the Comprehensive Assessment Test or quiz on the classification of matter. It's basically a dry run through before our DOG, our diagnostic observational grade, which is the test coming up very soon. So let's go over this um, uh, essentially quiz to see where you went astray, and I'm going to go through and walk you through this from the beginning. If you want to, should download a clean copy of this. I have this up on the website, so if you want a fresh copy to do this again with, you can. Notice also your key is posted through PowerGrade. Any case, let's get started. Mixtures. Okay, the first thing I'm going to do is find my mixtures. You know what? I'm going to start this way. I'm going to go look for my elements. I know that an element is a group of the same type of atoms. If I was to draw a particle diagram, I would see all of the same type of atoms. They could be diatomic or monoatomic, but they're the same atom. Each one of these, of course, is an atom. So, chemically speaking, we know that we have elements that make up these different types of atoms. And we know that each element has a unique type of atom. This is the red small atom. And we know that we should show a capital letter for each element with each different atom. So when I look at these, I'm going to first look for my elements. And I see I as an element. And the reason why I pick out I is because helium only has one capital letter. So I'm going to write I here. Okay? This represents helium. Helium is an element. It only has one capital letter. Look at the periodic table of elements and you'll see that every single elemental symbol has one capital letter. Look at F. F has one capital letter. Now, of course, it's bonded to itself. It would look more like, let's say, this, two of the same atoms bonded to itself. It's what we say is diatomic, but it's still an element because it's a group of the same type of atoms, no matter if they're bonded to themselves. So I and F are your elements. There's no other chemical symbols here with just one capital letter. This, by the way, is monoatomic, as we've seen, and this is diatomic. The monoatomics basically come from the noble gases, the last group. So those are my elements. Now, if elements are made of the same type of atoms with only one capital letter, then compounds would have two different. So if I had a circle bonded here and a clear circle and a dark circle, this group would represent a compound. Why? Well, they're made up of the same type of particles called molecules who have two or more different atoms. Two or more different atoms, two or more different capital letters. So here I have NaCl. NaCl is a compound. H2O liquid is a compound. Look at choice C. Choice C has, if you can see carefully, has 1, 2, 3 different elements, also a compound. You might say, well, D is a compound because I see more than one capital letter, but be careful. That aqueous there means that that compound, that molecule, has been dissolved in water, and that's a mixture, a special mixture we call a solution or homogeneous mixture. So that's not a compound, that's compounds, okay, or substances in a mixture. So back to where I was, oops, let's go back to that anyway. So let's go to more compounds, and E is a compound because it's a more than one capital letter, so an E is another. So let's write these down for compounds. We have our A, we have our B, our C, and now we have our E. Notice there's no more room left. This is not a compound because it's got the aqueous after this compound, which means that this compound is mixed with another compound called water, evenly homogeneous mixture. So those are our compounds. Well, who are our mixtures? Our mixtures, well, we know that D is a mixture because we've got a compound and water mixed together, so D is a mixture. And we know what else? We know that KCl aqueous is another mixture. So J represents KCl. It's what? A compound mixed with water. That's what the aqueous means. Where are my other mixtures? Well, Coke is a mixture. It doesn't have a chemical formula because it's a group of substances mixed together. Sometimes we call those ingredients. So Coke is a mixture. Five guys in a hot tub, that's also a mixture, right? You got guys and you have hot tubs. A lot of compounds there. Okay, so that's H. And then we have watermelon. Watermelon is water, pits, rinds, okay, not just mixed together. Okay, it's not one thing. So there are all my mixtures. Now let's look at number 3. Matter that can only be separated by a physical change. Well, that must mean they were put together physically and not ever chemically bonded. So we're really talking about mixtures. Mixtures are made physically and separated physically. So everything you put for a mixture should go here. So that'd be D, J, G, H, and K again. I guess I have to color coordinate this, which is tough for me. D, J, G, H, and K. The same mixtures. All mixtures are separated physically. Okay? Now, let's go to heterogeneous compounds. And you should realize that this is none. There's no such thing as a heterogeneous compound because compounds are a what? They are a substance. And a substance is either an element or a compound. It's made of the same thing. In the case of compounds above here, compounds are made up of the same molecule in a distinct ratio that does not change. So they can't be heterogeneous. They're the same throughout. So it doesn't exist. Okay? Homogeneous mixtures. Now these are from the mixtures that we just looked at here that are the same throughout. Now homogeneous mixtures, you should know, really represent something called a solution. A solution is when mixtures are evenly mixed throughout. And a solution is chemically denoted by this AQ here. So chemically, I know for certain D and J are mixtures that are the same throughout because they have been dissolved into each other. That is what the aqueous means. Not just mixed, but completely dissolved. Now there's another one. Coke is a homogeneous mixture, and it doesn't have a chemical symbol because it's basically made up of ingredients mixed together. But as you probably would guess, a can of Coke in Australia or Europe or America would taste the same because they're made of the same ingredients and they're evenly mixed, and Coke is a homogeneous mixture. Just like your buttery spread in Lab 3 is a homogeneous mixture. We know it's made of a couple different ingredients, but it's evenly mixed. Now, hetero means it's not the same throughout. These are from our mixtures. Notice we picked 3. There's 2 of them that are not evenly mixed. Well, 5 guys in a hot tub, no matter how you try to evenly mix 5 guys, it's tough to get one guy that's a clone of other 5 guys having a fifth of the water of the hot tub. Pretty impossible, so we can say that's heterogeneous. Besides, they're not dissolving. And then watermelon's pretty heterogeneous because you have what? You have the rind, the outside of the watermelon, you have the fruit, and you have seeds, okay? And they're different. They're not the same throughout. You could say, what about a seedless watermelon? Well, it's more homogeneous, but even them, they're not the same throughout. Watermelon is made up of the rind, the end, and the fruit. It's not the same throughout. It's not dissolved. Okay, rocks and sands on a beach are another great example, or topsoil. Okay, binary compound. From my compound mixture, we're looking for compounds that only have what? Only have 2 elements, right? To be a compound, you have to have 2 different or more elements. So in this case, you not only have to have 2 different, I should put different here, only 2 different elements, not 3. So if you look at our compounds, we had NaCl. Hey, that's 2 capital letters. That's why A is our answer, or at least A is one of our answers. Then we look at H2O. I don't care if there's 2 H's to 1 O, but there's 2 different capital letters. That's binary. Bicycle, that means 2. And now I go to C, and if you look at C, there's 3 capitals. There's Na, there's N, and there's O. These are 3 different elements. So this is not binary. And if you look at KCl, liquid, that's not the aqueous, it's the mixture, that's also binary. So ABE is your answer. Okay, so this is a compound C, but it's not binary because it has what? Not 2, but 3. Okay, a solution is a type of mixture, and you should all know this. A homogeneous mixture is a solution, so whatever you put for number 6 is what you should put down for number 9. And if you were to get something wrong on this quiz and you had the same ones here as here, I should give you full credit. Okay, a solution is a homogeneous mixture. It's denoted chemically by this AQ. All right, moving forward. Which of the following substances cannot be broken down into anything simpler? Well, my friends, in chemistry, the element is the simplest form of matter. It only has one capital letter. So this is Hg, one capital letter. This is only one type of atom. That's why it's A. This is the only one that's an element. By the way, it's mercury. Latin name is hydroguarine, or liquid silver. These have more than one capital, so this is telling you that these are compounds. This can be broken down into carbon and chlorine. This can be broken down into sodium and fluorine. This can be broken into hydrogen and oxygen. They have more than one element in their what? Molecules. This is just mercury. Can't break mercury down into anything simpler. Element is the answer. Who is diatomic? Well, if you remember, there's a mnemonic I gave you called Hofbrinkel's. H-O-F-B-R-I-N-C-L. All of these love to bond with themselves. We call them diatomic. Okay, for reasons we'll explain later in the year. So hydrogen is the first one. Notice xenon, argon, and helium are noble gases. That's the group 18, that column to the right. They hang out by themselves. Their chemical properties are they're inert. So they tend to be monoatomic. Okay, going down to the matching, which was hard for some. Intensive physical property, I for I. This is to identify something. I hope we can pick out density as our one here. Density is a physical intensive property. We've been talking about that too much. Extensive is based on the size of the sample, and that'd be CC. Chemical property. This is a property how well atoms will bond or lack bonding. So the non-reactive properties of the noble gases I talked about before, which make them monoatomic, is actually one of their chemical properties. Their inability to react is a chemical property, just like the ability to react. Flammability, burning, rusting, anytime you're making a new substance is a chemical property, or at least a measure of that. So E to the EE here. Okay, a molecule, you should know, is the smallest component of a what? Compound. So as I drew up here, this is one molecule, and it's made up of two or more different what? Atoms bonded. That's why it's touching. So I go find AA, two or more different atoms known as different. That's important. Chemically bonded into a single particle. A molecule is a particle. So AA is the best choice. All right. Element is made up of the same what? Atoms. The picture I drew above here. Oop, I was going crazy. These are the same atoms. This is one element. This is another, even though it's diatomic. Okay? So, element is a group of the same type of atoms. So that's your GG. Oop. All right. Compound is made up of the same molecules, right? We say a compound, this is a compound made of the same molecules. So that's why the best answer, I think, is a group of the same molecules is FF for 17. However, I will accept AA as well. And the reason why I'm accepting AA is because it's kind of a definition of a molecule which makes up a compound. And an atom differs by the number of protons in a nucleus. That's what makes the atoms differ. All right. Number 19, describe a characteristic of a compound or a mixture. Describe the characteristic. Well, in the total serial and magnet demonstration, we noticed that we were able to move a flake of total on water with the magnet. So the magnet moved the entire flake. It was attracted to it because of the iron on it. So what we can say is that in a mixture, because we knew that the iron and the flake weren't bonded, they just added the iron and fortified the cereal. We know that in a mixture, the individual components of that mixture retain their individual properties. Since iron is magnetic as atoms, it's going to be magnetic in a mixture because you have iron atoms and whatever it's mixed with. It's not changing itself because mixtures are made what? Physically. So if they're made physically, they're not becoming something other than what they already are. So if you're magnetic going into a mixture, you'll still be magnetic in the mixture. Components of a mixture retain their individual properties because they're made physically and broken down physically. That's what I was after. Okay, and number 20, the bubble demonstration. Remember, I had propane bubbles that sank to the ground, and I had hydrogen bubbles that went to the top. You could identify intensive, which bubble was which, by looking at which one rose, which would be the H2, which one fell, which was the propane. So you were using density, like we've been using for a lot of our labs, as a physical intensive property, eye for eye, to identify. Now, if you mentioned one went up and one went down, you were still talking about density as only one property. You could mention color. You could mention odor. All of these are great physical intensive properties that we can identify things with. If you mentioned blowing up, explosions, or combustibility, that would not be a good one, because that flammability or burning does represent chemical, and we're not after chemical changes. Chemical changes are not physical changes. So some of you guys said burning or combustion or flammability. That's not correct. Okay, moving down to backside. All right, what kind of change is occurring? Well, I know that if it's becoming a new substance, it's chemical. And of course, I know it's chemical because I can look at the individual particle that changed. These were what? Y and Z bonded, and now you have what? Y bonded to Y and Z bonded to Z. We changed the particles. So we changed the chemical here. So this is a chemical change. Why? You made a new substance. Many ways to say that, but you can say that what? The atoms rearrange themselves into a new form, new substance, new chemical formula. Hey, this could be HCl. Notice two different capital letters, and that's what would be this. And this could break down into what? H2 bonds to itself, it's diatomic, and Cl2. All right, and we can say 4 of these breaks it down to 2 of these and 2 of these. Notice the same symbol. That's an element. Okay, number 23. Box B compared to box A has, well, look at the choices. Same extensive properties, same intensive, same chemical. Wait a minute, there was a chemical change. There was a change in the arrangement of the particles. There's a change in the chemical formulas. Okay? So therefore, you don't have the same properties. You're going to have different properties. It's a new substance. So none of the above. You're going to have what? Different properties because you have a new substance. Okay, so they're not going to be anything that's going to be the same. That's why E is the answer. 24, which of the following correctly classifies the matter in box B? Well, box B is a mixture of two different substances. Here's one, here's another. This is element, and this is a different element, different group. So it's a mixture, not the same throughout, so heterogeneous mixture of two elements. Okay, 24 is D. 25, which box is made of matter that can only have fixed proportions? Now, if you have fixed proportions, that means you can only have, your particle is made up of only certain types of atoms. In the case of the first box, it was made of one dark and one light atom. These are compounds. This is a compound. The box A is a compound. So the only ones that have fixed proportions is your box that is a compound. Notice two different chemical formulas, two different capital letters, or just what? These are all made of the same molecules. So compounds have fixed proportions. This is only one dark to one light. Well, Mr. Grodsky, these are made up of two different things. Why can't these be fixed proportions? Because in a mixture, guys, can't you have what? More or less of these guys, or more or less of these guys? Can't you have a dilute or a concentrated mixture? Well, of course you can. So therefore, it has to be compound. Box A is a compound made of the same type of molecules. That is what gives it its fixed proportions. Mixtures are not fixed because you can have air with a little bit of oxygen, you can have salt with a little bit of salt, you can change how much salt and how much water, but in a compound you cannot change the ratio of atoms in the particle. Okay, number 26. Which of the following separation techniques, yes, I forgot the S, could be used for box B? Well, clearly box B is a mixture, and we separate mixtures physically. Distillation is separating a mixture of liquids based on their boiling points. We did that in class. We separated water from Coke. Chromatography, we separate things physically by their differences in solubility. We separated a dark black spot of ink into its individual inks that make it based on their physical properties of solubility. Centrifuging we did in a lab where we separated the dense layers from the less dense layers when we separated the buttery spread into its fat, oil, and water layers. Evaporation is when you boil off. We saw examples of this when we boiled off the solids, or the water, I'm sorry, from a homogeneous mixture and left the salt behind. That is what we did in our walk-around activity. And filtration, you can filter out solids from each other physically. These are all physical changes. Since guess what? Box B is a mixture, they're separated physically. So all of the choices, that's why F is the answer. Last question. In an experiment, a white powder is stirred into a colorless liquid. The following observations are made. The white powder seems to disappear, kind of like if you were to put what? Sugar in water. There's no fizzing or bubbles, no new color change, no new smell. What I'm telling you here is there is no new properties. If there's no new properties, then we didn't make a new substance. And guess what? The change is physical. And if the change is physical, we just made a mixture. Mixtures are made physically and broken down. And what we know about a mixture? The components of a mixture retain their own individual properties. So the properties of the liquid are the same after the experiment than it was before it. All right, I guess what I meant to say was the properties are the same. They didn't change. Why? Because in a mixture, you keep your same properties. And that's why 27 is A. Hope that helped. Okay, certainly if you've got a question that I did not review, give me an email. I'll answer it. Okay, go over, study your first Cat 1. Look at all the lectures, redo the worksheets. Find out what you did wrong on this and go find the lecture that reviews it. Go find the worksheet that does this. I know a lot of people did very poorly in looking at what? Deciphering between what was an element, compound, and mixture. And guess what, guys? I would review the walk-around activity. I would go over the lecture where I did this for you in a worksheet, and then I gave you the key. Take out the blank one. Redo it. Okay? Good luck.